day 78 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. You know how we do. This time we're at day 78. Hope you guys are refreshed. Hope you guys are well rested and ready to learn something today, because that's what it's all about. It's about learning and staying consistent and motivated to keep learning every day until we learn what we need to learn, which could and most likely will take years, guys. So put your seatbelt on and get ready for the ride. But before we get started, don't forget, guys, don't forget, bring your mouse right over here. Click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, I need all of my bankers, calling all of my bankers. This is not a drill. I need you in the comments section right now to drop 2 bank emojis in the comment section so we can run this engagement up and we can help build this Swift community and bring this Swift content to a broader audience so we can help grow this Swift community as a whole and get more people interested in Swift. Now, guys, with that being said, I know why you're here, the part you've all been waiting for, the question. And today we have question number 1143, longest common subsequence. The difficulty level is medium, guys, but don't worry, we're going to keep the solution as simple and easy to understand because we're all trying to learn here, and there's no point in coding something that nobody's going to understand or nobody can read, guys. So we're going to make it simple and easy so we all can learn something and we all could leave this video knowing something that we didn't know before. So let's see what the question says. It says, given 2 strings, text 1 and text 2, return the length of their longest common subsequence. If there's no common subsequence, return 0. A subsequence is a subsequence of a string is a new string generated from the original string, with some characters, can be none, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. A common subsequence of 2 strings is a subsequence that is common to both strings. So let's look at example 1 so we could break this down a little bit and see what it is exactly that they want us to do. So we have input text equals, it's a string of that's ABCDE, then text 2 is ACE, the output is 3, the explanation is the longest common common subsequence is ACE, and its length is 3. So let's break that down. We start with text 1, which is ABCDE, and then we end with text, and then we have text 2, which is ACE, and we want to count the longest common subsequence, right? So up here it says a subsequence is a string of a subsequence of a string is a new string generated from the original string, with some characters can be none, deleted without changing the relative order of the remaining characters. So in this case, we start with this and we have this, right? In this case, the B was deleted and the D was deleted, right? And that left us with ACE. ACE is still in text 1. Text 1 has an A, it has a C, and it has an E. So we could count all of these letters as the subsequence, and since they're in the same order, so that's why the output is 3, because both texts contain A, C, and E. In the text 2, we just deleted B and the D, right? So let's look at ABC so we can, let's look at example 2 so in case they try to give us a trick question or something, because example 2 is kind of like a trick question. So in this example, we have text 1, which is ABC, and we have text 2, which is ABC. The output is 3. Explanation, the longest common subsequence is ABC, and its length is 3. So in this case, you might say, well, nothing changed. So it doesn't matter if nothing changed, because right here it says some characters can be none. With some characters can be none, deleted without changing the relative order of the remaining characters. In example 2, we're dealing with this can be none part of the subsequence definition. So in example 2, no letters were deleted. We started with ABC, and in text 2, we still have ABC. And since text 1 has an A, a B, and a C, they all included in the subsequence, and that's why the output is 3. So let's look at example 2 in case they try to throw another little trick our way. We'll catch it and see what they did. So in example 3, we have text 1 equals ABC and text 2 equals DEF. The output is 0. The explanation, there's no such common subsequence, so the result is 0. So if you look ABC, then we have text 2 DEF. There is no DEF in text 1. So there is no, since this is DEF, there is no common substring because we do not even have, excuse me, I don't know what that is, but because we do not even have a DEF over here, then the output is 0 because there are no common characters in text 2 or text 1. And if they were common characters, they would still have to be in the same order. But in this case, there are no common characters, so there's no common subsequence. Now that we understand what the question is asking, let's get into the code, the fun part. The first thing we're going to do, we're going to say let n equal text1 dot count. Then we're going to say let m equal text2 dot count. Then we're going to come down here, we're going to declare a variable, we're going to call that DP. That stands for dynamic programming. If you were unaware, we're on the dynamic programming part of the LeetCode 75. So that's where the DP comes from, for dynamic programming. And we are going to set that equal to an array. And then we're going to open up the parentheses, say repeating. But this is going to be like a 2D array. So what's going to be repeating is going to be another array with repeating. That array is going to have repeating zeros, and then it's going to have a count. Count is going to be m plus 1. Then we're going to come outside of those parentheses, but still inside the original parentheses, and we're going to put a comma because this is going to be the count of the original array, and that is going to be count colon n plus 1. So now that we did that, we're going to come down here and we're going to declare some constants, and we're going to say let text1 array equal an array of text1. Then we're going to do the same thing for text2. We're going to say let text2 array equal array text2. Then we're going to come down here and we're going to start our for loop, and we're going to say for I in 1 through n, open up the brackets. Then we'll say for j in 1 through m. Then we're going to come down here and we're going to say if text1 array is equal to, text1 array, we're going to open up the array brackets. We're going to say I minus 1, or I minus 1 is equal to, so we're going to put 2 equal signs. Then we're going to say text2 array, open up the array brackets. Then we're going to say j minus 1. Then we're going to come over here, we're going to open up some brackets, and we're going to say dp. We're going to put the I in like index I. Then we're going to do the same thing for j, like index j, but they're going to be separate, and they're going to be separate index array things. And then we're going to say equal dp. Then we're going to open up the array brackets. We're going to say I minus 1. Then we're going to come outside those, and we're going to say j minus 1. Then we're going to come outside, equal white space on both sides of the minus sign. Then we're going to come over here, we're going to say plus 1. And if that doesn't work, we're going to say else. We're going to come down here and we are going to say dp. We're going to do the same thing, open up the array brackets I, come outside that, do the same thing for j, open up the array brackets and put the j inside. Then we're going to say equals. Then we're going to say max, open up the parentheses, dp, open up the array brackets I minus 1, come outside that, and we're going to put the j, or we're going to say comma. Then we're going to say dp, open up the array brackets I, come outside that I, open up the array brackets again, say j minus 1. Then we're going to come down here and we are going to return DP, open up the array brackets M, and do the same thing for M. And that's all she wrote. Let's run it and see how it runs, guys. Fingers crossed, fingers crossed. No bugs, no typos. That's what I like to see, guys. Get one more look at the code, get one more look at the code. But let's submit it and see what happens when we submit it. So fingers crossed, fingers crossed. What's it gonna say? 20% of 20 milliseconds beats 85.23% of users with Swift, guys. Now that's not too bad at all. I hope you guys learned something today. Go over the code, look at it, live it, learn it, love it, guys. And I'll see you guys tomorrow for another day, another LeetCode problem. Peace.